Hello, everyone. Welcome to another episode. My name is Anton Babienko, and today we will be talking about CI/CD pipeline for infrastructure as code. Specifically, we will be talking, of course, about Terraform, but it's not really related just to Terraform. It's my pleasure to have such a special guest today, the person who actually inspired me to do. Oh my God, somebody said, I cannot hear you. That's bad. You should be hearing me because my microphone is working. Can somebody confirm that you can hear me? I can see that it's moving. Yes, I can now. Okay, thank you very much, Sohan. So I'm not gonna to repeat what I just said, but I just want to say that uh, I started working with infrastructure as code after I read the book by Kief Morris, who is going to be joining me in a minute. And uh, what is actually special about this episode? Well, I have to be honest. I have very hard time finding people who are knowledgeable and who willing to participate and kind of share expertise on my live streams. And it was just absolutely a pleasure to know that Kiev accepted it, and I was over like excited. So then I was preparing for this live stream. I was reading some of his blog posts. I previously read the book, which is called, quite obviously, Infrastructure as Code. And I knew pretty much what kind of position Kiev says, or Kiev advocate for a few years now. So I was well prepared about what to expect, what to know. But as I move through the preparation, I realized that, oh my God, there is a lot of value for this stream to be shared with the public. So without further ado, I'd like to just introduce Kiev, and we will take it from there. I think it will be interesting. As always, if you guys have any questions about what we're talking or you want to ask some clarification questions, don't hesitate, and I'm sure that we will be able to answer you. So now I have, of course, I have difficulties, or not difficulties, I have to figure out which button to click to add Kiev properly. So let's click left or right. There are two buttons. Let's click left. Yes, it works. Okay, now you're from the left. Great.
Swipe
Welcome,
left. Hey,
Kiev. Yeah. Well, it's cool. It's cool to have you here today. So
yeah,
let's.
thanks. I mean, yeah, it's really kind of it's a pleasure to be here, and so thanks for inviting me to talk with you. Should be fun.
Yeah, it should be fun, and I will try to monitor chat because people are gonna to ask some questions. I really hope that you guys will ask questions. You see, you should ask questions. And yeah, and if you're not going to ask questions, we will have some things to talk about anyway.
Yeah.
So let's start with the book, maybe. Like you wrote this book, and people can see my browser, I guess. Yes. So you wrote this book twice.
Yep. Yep.
That's pretty cool. I think, yeah, I read it around June 2016 because
Wow.
before June I was clicking absolutely randomly inside of AWS console, and I had actually a hard time understanding why people should be using infrastructure as code. Like I was clicking and it was, okay, works, doesn't work, who cares?
That's
And then
that's really cool here because I mean that's why I wrote it, right? Because it's like and so that was right about when the first edition came out, I think, wasn't it, June 2016? Um, and like the reason I wrote it was like, so like infrastructure as code had been around like as a term for which is around 2009. I think that's when the term was kind of first emerged, and it had been around before that with tools like CF Engine for configuring servers in this way. And so I came across this. There was a website called infrastructures.org, which I think is still around, but the
yeah,
content
yeah,
hasn't
it is still, yeah.
been. Um, it hasn't been updated for ages, but it was great. Right? It was really based on like in those days, it's like I'm talking like mid 2000s or maybe even a little bit early 2000s
It
when I
has
came
not
across it.
changed. The website is still there. It has not changed since 2007.
Yeah, it's a great piece of kind of like, I don't know, history and to understand like where all this stuff came from. Because back then it was like, so when I started, it was we had physical servers in our data center and some racks, and we would use like Pixie booting. So you would boot the server and it would like go out. You have all these kind of stuff with THCP and TFTP boot and stuff, and the stuff is still around, especially if you're working in data centers and trying to automate infrastructure. So it's like you would like have the server like automatically boot a little image and then like hook in a tool like at the time CF Engine was the tool like for doing server configuration, which then like Puppet and then Chef and Ansible all came along to kind of do fill that kind of same kind of gap. And so I was doing this kind of stuff, and then like uh, Amazon came out with like EC2, and then all that kind of stuff grew. And so, but first there was like virtual servers, so that was like a cool thing. You could create servers on demand on your own hardware, and then cloud infrastructure as a service kind of stuff came out. So all this stuff became like more and more, all these things fit together and really cool. And I was learning from other people like blog posts and conference talks and all that. So like I wasn't one of the people who pioneered this space, but I was it, kind of like yourself, someone trying to figure out, like you were at the time, trying to figure out, well, how do I use this stuff, how do I make it work. Also because I joined ThoughtWorks in about 2010, and so I spent a lot of time going to clients where we're doing like software delivery projects, and they wanted to do continuous delivery, path to production, and that leads into like the topic of today's talk, why I kind of got into that. But we're doing that. People wanted us to do that for their applications, right? Use pipelines to do automated deployments and testing. And like environment consistency was a big issue, and so infrastructure as code was really relevant. And so I would be constantly talking to clients and explaining to them, you should do this, and here's why you should do it, and here's how it should work. And I was like, man, it would be useful if I had like a book, that like one of those people who were the pioneers in this space would like. I was expecting one of those people, I don't know, Andrew Shea Clayfer or Pat Dubois, or there's a bunch of those people. Who like kind of pioneered this stuff, and the whole DevOps movement was a part of all that. So I was expecting one of them would like write this book, and then I would be able to show it to my clients and say, look, here's the way. And then it was probably around 2004 or 5 when I think I was an editor like approached me and said, hey, would you be interested in writing some kind of DevOps book? And I said, you know what? Maybe I'll give it a go, right? And so yeah, that was it, right? That was kind of the inspiration for writing that first edition of the book. And then 4 years after that, it seemed like enough had changed in the industry to come up with the second edition.
Right. So your book was about infrastructure as code, and you clarified a lot of terms, a lot of concepts around infrastructure as code, because it was not enough information, and you suddenly start to introduce people to different concepts. One of the concepts which we are going to talk today is related to pipeline, to promotion, and that's specifically what I think we can talk today. So can you maybe in I don't know, elevator pitch format explain what is CI/CD pipeline for
Okay.
infrastructure as code?
Okay, so I'll start with kind of applications because that's where I think it's a more familiar concept for a lot of people. And so the idea is that you write your code for an application, you build it into a deployable package, and then you run automated tests on it, unit tests and so on, and then you deploy it into an environment. The idea is that you have some automation around how that happens in each environment. So you have a pipeline which automates the process of deploying the application into the environment. And so even where you might have human approvals for deploying into a stage, you might want to have somebody who like kind of tests it, make sure, are we happy with it? From a compliance point of view, you might need to have people kind of review it and kind of sign off on it and say it's so you can tell auditors, looks, a second person has looked at it or whatever it might need to do. But then you click a button, and the same kind of automation process happens to deploy it into the environment. So the same thing is happening each time. And it was to get away from the whole thing of where people struggle, where people spend like a day, like you get a release of the software and it takes like a day to get it working on the test environment. And then, so then, testing happens for a while, and then it's like, we're going to deploy it to the next environment. And you have to have people kind of deploying the code and configuration of files. And it's different, right? Oh, it doesn't work in the staging environment, say, because even though it worked in the the dev environment or test environment, and then you try to deploy it to the production environment, oh, it doesn't work quite there as well because of differences. And so the whole idea of continuous delivery is to try to make that whole path really seamless. And just in terms of the terminology, because we were talking about like what's the difference between CI and then continuous delivery, continuous deployment. So continuous integration, that kind of came out earlier, and continuous delivery built on that. And that was the idea of just as you write code, you commit it, you push it into a branch where other developers are pushing their code, and every time somebody pushes a change, something picks it up and tests it and makes a build. And so that way, every time somebody commits a change, you know that the tests are run, and did that change break it or not. And so continuous integration is really about that, just that kind of first step of like, the commit, does it hang together? Do we need to build something and prepare it so that it can be used later on? And then continuous delivery kind of extended that concept to the rest of the environments in the path to production to say, can you take something that's been built and tested and deploy it in each environment, maybe run automated tests, maybe give people a chance to do manual testing or sign-offs or what have you. So continuous delivery, I think the root of continuous delivery is the idea that you should try to make sure that your code base is always ready to go through to production. That you don't kind of, even if you have features that are maybe not completely implemented, you have them built in a way so that if the code actually got into production, it would be okay. Maybe the feature would be hidden, or maybe enough of it is there that it's okay for users. So that was continuous delivery. Continuous deployment is, and the difference between continuous delivery and continuous deployment in terms of terminology is just, it's kind of arbitrary, right? I don't think you can kind of debate what those two words mean and what the difference is, but that I think it's just the concept is more important. That continuous delivery means you're ready to put your code into production whenever you want. Continuous delivery is the idea that like it actually does get pushed. So you probably don't have manual reviews in those stages. Like a developer pushes the code commit, tests get run, automated tests get run, and if they pass, then it ends up in production. And that's a little bit scarier for a lot of folks, for anybody really. You have to have really good kind of tests and monitoring and all those kind of things to be confident you can do that. So for most people, continuous delivery makes more sense. So I hope that makes sense. I can talk a little bit about the infrastructure then, like why and how I decided to apply that to, or people have decided to apply that to infrastructure. I just want
Yeah,
to
I
make
think
sure.
the clarification makes perfect sense. Just to put it like for people who are coming from software development background, they spend and they have been historically spending a lot of time on CI phase, like how to run tests, how to build something, how to package something. Like that's where a lot of energy was spent. With infrastructure, we usually taking care about okay how we can actually propagate it somewhere, how we can deploy it to one environment and then promote it to another environment. So that's where the concept of pipelines in infrastructure as code, at least to my understanding, is more meaningful. And I really like the quote which you have somewhere. I don't remember where I got it, but like you said that CI, I think you said about continuous integration. This is software delivery 101. Always test a new build in a staging environment before deploying it to live. And for many people, it may sound like, oh yeah, that's common sense. But I really like the clarification of this one, where some people said, it was not a long time ago when I read this quote, but I don't remember where I got it from. The quote was, "We all have staging environment, but some of us are lucky enough to have it separately from the production one."
Hmm.
So we always test something somewhere, and people can say like, "Oh yeah, but we don't have test environment." Well, you can always test in production.
You do have a test environment. It's just that it
Yeah,
might be
you
that
have test
your
environment.
users and your
Yeah,
business may be running on that test environment,
yeah,
right?
well,
Yeah, it's an interesting twist for infrastructure as well, because what's the production? environment for your infrastructure code, right? And I had this. So in an earlier project before kind of Terraform and all that, we were working on VMware actually, and we were using Chef to configure our servers. And so we would work on our Chef code, and we would apply it basically to our dev environments that our developers and testers were using to test the application code. And then I pushed a change that broke it, right? So it was, at the time, the way we had it going was we didn't have control over our DNS in this environment, the company that we were working for. So we set up a hosts file on the servers so that an application running could connect to a host called DB, and there was an entry in the host file where the DB would map to the IP address of whatever the database server was for that environment, right? And so we would have our chef code would like write the hosts file based on in this environment's QA environment, so the database is this IP address. But then I changed the cookbook that created the host file, and it made an invalid host file. And so then like nothing could connect to anything. Like those servers, you couldn't SSH into them. They could, you couldn't go in even to fix the problem. Like even if I changed the cookbook, like no connections would happen to pull down the new version of the cookbook and apply it to the server, right? So I broke dev, and it was like, it took like a day to like fix that. During that day, our developers couldn't work, our testers couldn't work. They were all just kind of sitting around, having a good time while I was like sweating over fixing this thing. But it really brought home to me that like, for infrastructure, quite often, if you're working, you're building infrastructure for development teams to use and all that, like your production environment is a development environment, it's a test environment. And so since then, I've always tried to make sure to have an infrastructure test environment where I can test my changes before I push it out to people who are going to be unhappy if I break it.
Yeah, we have a quote from, I would say Tigran can easily represent Armenia. So Tigran says, always test in production and do releases late on Fridays. Thank you very much, Tigran, for advice.
Yeah,
okay.
Yeah. You'll learn, right? You'll
Yeah.
You have to be good.
That's good. Okay, let's focus on.
Oops, it lost sound on you. I can't hear you, Anton, now. Still can't hear you. Don't know what's changed. You were just talking along. Technology, huh? Oops, I just realized there's a chat window. I didn't realize I could see the chat. Ooh, people are saying there's a when I'm talking. I don't know about that.
Test on prod. Okay, now you should hear me, but
I can hear you now.
Then I need to mute. Yeah, then I need to mute. This is really like a release on Friday. Sorry about that, guys. But okay, so what I was about to say before I accidentally muted myself without clicking anywhere. I just wanted to say that we have more or less figured out that there is CI/CD or CI/CD and CD pipelines will be, because that's what make most sense with infrastructure as code. And let's talk about different types of pipelines. So there are, let me find this one. Yeah, this one is, sorry, this one. No, this one is the same. Why I opened it? Defining stacks, right? Okay, pipelines. Let's talk about what exactly we can put into the pipeline. So the first thing which you guys already know if you attended pretty much any of my previous Terraform streams is that Terraform has modules, right? I mean, modules is in essence collection of Terraform file which creates, of course, parameterize them, you can version them, you can do a bunch of different things with them. And that's exactly where the first term, which is kind of relevant to this conversation, is that there is an infrastructure stack. So what is infrastructure stack? Let me try to unmute Kief and mute myself.
Okay.
And what kind of definition it has, and some other properties of it, so that we can talk about it as a component we put into a pipeline to do some promotion.
Okay.
So the first definition, as I said, stack. I'm clicking. Sorry, it doesn't look so professional, but it's Friday. So in essence, with Terraform, what we have is that we have stack definition, where we have some sort of Terraform module, which we have inside of Git repository. And then when we want to instantiate it, we create stack instance, and we impose in infrastructure from this stack. Right? Did I miss something?
Sorry, are we having echo? Am I okay to talk? Okay. Sorry about that. So I think it's interesting, the module and stack thing, because I think in some cases a module would be used as a stack, but I'd draw a little bit of a distinction between them. So when I talk about a stack, I kind of describing like a deployable thing, like something that you can deploy on its own. And in some cases, you implement that is you write a module, which is like, these are all the things that you're going to deploy together, and you put it into a Terraform project. So when I talk about Terraform, I would correlate a stack, and especially a stack definition there, and that is it's a Terraform project, right? It's something that when you can run Terraform apply on it, and it's going to create some things in the cloud, and it's going to have a state file, a single state file that contains the information about what's out there in the cloud and how it correlates to the code and your definition. And so, whereas a module, I think a way that a lot use them is kind of like a library of things that you might include in a stack. You might have multiple modules in a single, a stack inside, that you import into multiple projects. And so I think that makes an interesting distinction, because to me, like, a module can be a good way to organize code and to like use. So I know you make modules, that you available for people to use on their projects. And so that becomes very, like, say, I always go to Java is one of the languages that I used for in my early kind of career. So I talk about that like a Java jar file as a library versus maybe, I don't know, a war file or something, which is an application that you bundle libraries into it, and then you run it as a run and deployable thing. So and so that in terms of a definition, that term of stack, the reason I use that is just because I'm often talking about patterns, and I go across different tools, so they can be used in Terraform, can be used in CDK or CloudFormation or Pulumi or whatever. I always needed a term, just a generic term, to be able to like describe that unit of something that you pull together and deploy or apply as a unit. So that's where I would call that.
Right. So that's pretty clear explanation of what is stack, and I think you're right that when I look into this stack definition, each of these Terraform file may contain invocation of many different resources, or maybe different modules, different types of stack, kind of hierarchy of modules, for example. Inside of Terraform best practices, I call it, I mean, it's very hard to figure out names for all of this, but that's what I call a composition. So the composition is actually a collection or group of several resource modules, or it can be infrastructure modules, and all of this hierarchy creates infrastructure composition. I know that naming is not the best part of our kind of journey, but I think many people agree that stack is really like collection of something what Terraform has for us to provide. Data sources, resources, other deployable unit. And when we have this deployable unit, what we can do as well, let me see. Then when we have this deployable unit, we have possibility to put it somewhere. And that's where the process of environment and not process, the definition of environment is pipeline is actually come in action. I read this article many years ago, and even now, I think, I mean, it's 2017, but it still has a lot of common sense which is applicable right now. Once you have some deployable thing like stack, you want to put it into some process. And what's the point of putting it into the process? How do you think? Cannot you just copy paste files between? If I look into this one, so this is another talk you gave. Why? I mean, if I have my integration environment, my local environment, my production environment, why cannot I just I don't know, have 3 different folders and do changes? Let's say in production, change in development. Are there any problems with this?
Yeah, I think that was a leading. No, I have a opinion on that, right? I think you can, right? People do that pattern of having a separate folder for each to the environments, and a separate copy of basically like a Terraform project, and then like you edit them, you apply it, you test it to make sure it's open, you kind of copy those changes over to the next environment. So I call that the flakes as code, because it's hard to keep those environments consistent from one next. It's easy to make mistakes. Oh, I'm hearing something really weird. Okay. It makes it easy to make mistakes to where like, because what happens is you tend to then have differences in the code for each environment. Like, okay, the cluster is going to be different. It's going to be bigger in print than it is in testing maybe. Or maybe names, like you have like some strings somewhere, which like you're naming things, dash staging or duction or whatever. What's very easy to fall into in those cases is the situations where list of things, when you copy the code from staging into production, remember to take these steps, edit these things, rename things, whatever it may be. And then that's where it happen, right? And so you would like process. The idea again of continuous delivery is that, you don't have to think how to promote changes from one to the next. It's like click a button if you're happy with it. Once you're happy with it, and then the script should run. It should apply code, and where you do need differences between environments, rather than put to the code of the stack itself. You have those separate as parameters normally to say you want to parameterize those, like cluster size, max as parameters that you have separate as maybe a file environment or in a parameter store or something like that. So that when you apply the code to a given environment, it's the same. You just take the code and copy it. You don't even get the code. You worked in this environment, apply it to the environment. You don't copy the you just kind of apply it in each environment, and but you just kind of point in, here's the parameter maybe to use for this environment, and so you kind of keep those minimal. So that's my kind of recommendation really, and guidance is on avoiding the separate folder per. And this, I don't know if you mind if I kind of jump ahead to, I saw one of the people in the chat asking about GitOps, and I think that GitOps is an interesting thing because there's like depths of GitOps according to what the Cloud Foundation, or kind of, they got a working group. It's like what a lot of people do in practice, which maybe doesn't necessarily fit with that definition. So I would say if you think of GitOps as branches, to have a branch for each environment, that can be okay. The whole question is, how do you promote code environment to the next, especially if you need different. So we're applying a version of the code to production. Meanwhile, working on changes, the next set of changes, and we have to wait and then work on those. And then we want to be able to have. And so one way of containing what's the version of the code that we have in each environment is by tagging, for instance, and saying like, we're going to tag it when we apply action. I think the really key thing for me, personally prefer to use branches for that. I think it gets too easy to fall into that same pattern, that snowflakes as code pattern, where you merge the code from one branch to the next. It's going to be applied there. It tempts people to say, and then you edit things before you apply it, right? I think if you are using branches in this way, you should avoid that. And if you look at going back to what I said, definition of GitOps to the Cloud Native Computing Foundation, one of that the code that's in a branch is automatically applied, so you don't get a window of opportunity edits to that branch. Once you push the code to that, it automatically be applied and then reapplied and automatically. So you have something, whether it's a tool like Flux or something that's sitting there and looking at the branch every time it changes, or not even every time it changes, all the times I make it the same. If not, I'm going to make it the same. I'm going to apply it. And so that's like a really pure GitOps pattern that also kind of will tend to that discipline of like, put it another way, you should be able to have a pipeline emerge for you. You click a button and it merges for the branch for say the stage environment and makes it the code for the production branch. And like, again, there's no manual intervention. You're not thinking about what to do or taking steps. It's just, it happens, and it happens the same way every time. It forces that discipline. To me, that's the important thing, is having that discipline. You're not changing code between environments.
Yeah, that's a really good point that you highlighted.
Anton, something's really funny with the voice, at least for me. I don't know for other people.
I don't know.
It's very crackly.
To adjust volume everywhere, but I don't know. I think it's okay. It's not going so high, but you become a robot. Oh my god, that's not what we want. Let's see. I still have plenty of options
to adjust.
Oh, better.
Yeah. Okay. Good. All right. So, well, thank you everyone for telling. I completely forgot what I wanted to say. No. No. Anyway, as a robot, I like a little bit. When we talked about what kind of a deployment unit can it be, when we talk about this as deployed as instance or stack instance, we have some configuration. So we pretty much always have to point, like in terms of Terraform, we need to point which stack we are talking about, which version of a stack, plus which values, because everything is parameterized, I mean, to some degree, of course. And that's exactly the point. So when we are making some sort of pipeline, like here, from the point of view of the pipeline, the only changes which has to happen here are values which define each of this environment, right? So difference between local test, cloud test, integration, production, and other stages or other environment is not extra resources being added on different steps, like ad hoc, but it's pretty much which set of key values we are providing to each of these. Otherwise, we are not going to test the same things, right? It will be different things which we're testing. So it's quite easy when we are deploying something to, let's say, stage environment. We may say like, oh yeah, but I want to save some money, so I don't need NAT gateway, I don't need some extra resources, I don't need load balancer. Well, but then what are you testing? What do you really want to test? The whole point of that is that your stack should contain configuration where you can easily generalize certain things. But that's like in theory. Of course, we need to have some exceptions, and we don't want to deploy the most expensive things everywhere.
Yeah.
Okay. Talking about anti-patterns, you again wrote this post, which I think is yeah, it is as you. So this is one of the most recent. That's good. So when we're talking about snowflakes, like you just mentioned that this is an anti-pattern, can you explain like one more time why exactly it is anti-pattern? Like, I mean, I understand that you have kind of good intentions, but don't we have some sort of excuse. Oh my God, I don't want to pay a lot of money. That's why I don't do this exactly like canonically, identically everywhere. Or like I want to have a little bit different, a little bit extra things on production, but I don't want to put it, or I don't know how to put it into code. So that's why I apply changes in. So I have my pipeline, but I also have like resources being added, extra things being modified as like through console. Um, can you explain what is bad there? Because I'm pretty
Yeah.
sure that a lot of people who are listening this, they think like, yeah, but I have a decent excuse to have this in my code. I mean, I'm working with such companies myself from time to time where things are, we have a lot of extra excuse on each steps.
Yeah, I mean you kind of understand why people do it, right? Because it's easy. And really, I think it's a learning thing, right? Because sometimes you have to like um, I think get away from needing to do those manual things and those differences, and how to kind of parameterize and learn how to manage that. So it's a learning process. But I think the reason to avoid doing that and the reason to make the effort to kind of learn in habits, to where you're not having to do those things, it's because the more manual things that you're doing and the more changes that you have to make from one environment to the easier it is to make a mistake, and cause an outage or just to take a long time, right? So one of the things that I find is that where it's a bit of work to promote code from one environment to the next, it it takes time and it takes effort, and people kind of looking at it, and so it's slower, it slows the process, and that means you change it less, right? And then what happens is technical debt creeps in, because you have like, oh, here, this isn't quite right and I want to fix it, but it's going to take a while to kind of apply it to each environment, all that, or patches even, and things like that. It's like, oh, are we keeping up with patches? It takes a long time, right? Every time we do it, we have to go through this, and we worry that mistakes, we wait, let's leave it for later, let's and so I think it's sort of like saying that if we can make it just really so that you don't have to think every time you think, when you're making the change, you think about it then, and you test it. You make sure you have tests to kind of test that change properly, um, and you make sure that like in the kind of you're wherever you're developing and testing the code. But then after that, just don't really have to think about it very much. It's just kind of click it, put it in the other environment. Hopefully, have automated tests that test as the application still deploy correctly and still work correctly and pass its test. But hopefully, that's all automated too, right? So it means once you've kind of made the change in the code and you're happy with it, you push it through, and it's just the thing that slows you down the most is waiting for Terraform apply to finish finish running, right?
Yeah, that's definitely the case. I just wonder, since you mentioned it has to happen as early as possible in the process, and then after this, it has to be automated, uh, like pretty much with the same script, with the same flow. Uh, do you have kind of suggestions, or do you have maybe advice or experience? What kind of things should focus when they are working with, when they want to deliver uh, code or configurations which will be easier to put into the pipeline? Like, for example, make things parameterized, don't hard code some crazy things, something along
Yeah,
those lines.
yeah, those are two obvious good ones, right? Pull them out into parameters. Don't have coded, and I would say where you have logic, so you might have those variations. Like we talk about, you're going to put in a parameter which says like how big a cluster is. Like you say, we don't want to pay too much money for a dev environment, a QA environment. We don't need a master size, maybe for an auto scaling group or a Kubernetes cluster. So parameterize that. But then you start getting into, I think another thing is sure that in your code you're not aware of the environment. So another thing I have personally done and that I don't recommend doing is you have code, Terraform code. It's like if environment equals, set these things, if environment equals, and so I don't think you have inside your Terraform code, you should have awareness about environments and what environments there are and so on. I think that, and this gets into kind of software design. One of my favorite themes to talk to look at like principles and practices from design, things like the solid principles for object oriented, or the Cupid, which was the first post. Currently the post, which I think is probably quite old now, on my on the infrastructure website. These are aimed at software developers and art and design, but they're good things to kind of know about and think about for your application. And so this is where that thing of, should your application code, or should your infrastructure even know about the environments that it's deployed in or not, right? Because that's how you make it kind of easier to kind of manage and change and test, as to where all I care about a bit of Terraform code that's making an auto scaling group is like, give me a parameter for the size, maybe even give me a parameter for like the AMI image to use, and other things. Just give me the parameter and I'll what needs to happen. And then the thinking about, okay, what is the right image to use, or the right cluster size, goes somebody who's thinking about environments. And that also makes it more flexible. Like you can create it on the fly, right? You could say, I want to demonstrate to somebody this thing, but I don't want to use an environment because people are trying to use that currently to test. So I can make an environment, I'll make the parameters and run Terraform with that set of parameters. And now I have a new instance of the stack that I can use to demonstrate something out. And that's harder to do if your code it only knows about environments, right?
Yeah, I really like your comparison, or your the way you explained that putting some condition inside of Terraform code, which has to be expressed one level above, is wrong. So people should not know about where this certain piece of code will be used. This should not be part of the module itself. It should be like one level above. For example, go to documentation and they read about Terraform workspaces, and then they want to use it in, let's say, count, where they say if terraform.workspace equal prod, then do this, else do that. This shouldn't be happening inside of module, or inside of stack, or inside of pretty much any form, to be honest. But that's what we have right now. I think that, like you said, applying software development or software engineering principles, which we learned for pretty long amount of time, like Solid, or recently what Dan introduced, Cupid, or many software engineering. That's where we should start. I know that a lot of people think that, oh, Terraform is just like HCL is just configuration language, so I can do whatever I want and disregard everything what I was told. But that's just kind of, it's wrong. I mean, we know that we are working with software engineering at the end of the day anyway. So yes, we use different tools, but I remember that like pretty much going to Wikipedia page and learning about solid principles one by one, slowly understanding how this can be applied to Terraform code was such a big help for myself. Like, I don't know, 2018, when I read it carefully and slowly, thought about each of this principle and how this can be introduced into Terraform. That was actually the main driver why I thought about this key concept the way I described it here, because it's just natural to think about this as a software application. I know that HCL is not programming language, but that's not the point. Okay, cool. Guys, yeah, there is a question from Jose that you have been using. Yeah, of course, I will put them in the description on YouTube page. Well, all of this is actually infrastructureascode.com, but I will put links to these specific articles. Kief is not writing so many articles, so it's not hard to find all of them. Once a year, that's enough.
Yeah.
That's good. Yeah. So feel free to. I'm gonna to to ask a little bit about ideal pipeline. Like we talked about what is pipeline, what kind of stuff can be promoted. We talked a little bit about anti-pattern, like Snowflake as code. Looking into your previous assignments and where you saw pipelines being implemented, is it right to say the continuous, what is it? I forgot the name of the category where Jenkins belong to. Like continuous integration tools is not the problem. The problem is usually how people write code, how they write these small shell scripts which will be invoking different things, what they're actually invoking. And Jenkins, GitLab, Spacelift, or M0 is not really gonna to automatically solve all of your problems, right?
Yep. Yeah. So yeah, I think that's right. And somebody's asking about the pros and cons of different tools, CI and CD tools, for using Terraform. I think like most of them are fine, right? They're general purpose. I think the important thing is to not put too much logic into the tool itself. So most of these tools you can write kind of like you can, like in a Jenkins, you can like have a job and you can put in plugins that put all kinds of things in there. And what happens then is you become really coupled to that job. And so it's like if you're trying to test it and figure out, debug it or whatever, you can open it from Jenkins because all the logic and information about like running. So for example, right? You don't want to have all the logic to figure out, we talked about having per environment, where do those parameters live? It shouldn't be in like Jenkins job configuration and plugins and all that, at least not unless it's very simple, unless it's just here's the list of parameter values, that's okay. But like if it gets more complicated, I think that's IaC is where that becomes very complex, and then you can't kind of run it the same locally, or because sometimes it can be useful to run Terraform locally with like a plan against one of your environments to see what's going on there if something goes wrong, right? I think that's main thing I would say is it's like just keep that kind of logic kind of separate, not too tightly coupled to the and then the tools. I think it just becomes like some of them are easier or harder for you or work. I like tools that show the connections between jobs in a pipeline. So a lot of tools which were originally designed just for continuous integration, just for commit a build job and then you're done, showing the progression of build pipeline isn't as good, although there are plugins for that in more recent versions, a little bit of a better job. But there are tools like Concourse CI and GoC, which give you a more visual, for more complex pipelines, we have different components tested individually and then integrated. Those do a bit better job where they have their own challenges. So I was like, in terms of a favorite tool, like a favorite tool right now, I'm using GitHub Actions just because it's easy to implement. But I haven't really mastered how to make pipelines really well between those GitHub Action, kind of workflows. It's something I'm still learning myself.
Yeah, I think GitHub Action is taking pretty solid place when it comes to illustrate and show workflow. But GitHub Actions works pretty well when you're doing something in one place. If you want to do like some chain of operations, for example, once you deploy this environment, then wait for some approval and deploy to another environment, this is where GitHub Actions currently are not kind of are rather limited. There are some. There is what is it? Step or GitHub Action. Yeah, I think GitHub Action Step it's called, which is doing manual approval. So you can actually set up your own pipeline and literally wait for up to 72 hours for approval to happen, because 72 hours is a maximum how long your job can exist. So that's it's okay, but yeah, it's not native, I would say. You can do quite a lot with GitHub Action. And Tigran also asked, in terms of pros and cons using with Terraform. I personally think that a lot of companies who are providing Terraform automation solutions right now, they are doing pretty good job because they take out to run Terraform. Like they abstract away what is state, how to secure your state file, how to make sure that only correct people will have access to certain things on your infrastructure. So I think they are necessary and they still be developing. But
I would say,
it's pretty hard to.
yeah. So I think those tools are interesting, right? So I think maybe Atlantis and Terraform Cloud come to mind, and I know there's probably a few others rattling around out where people are making kind of Terraform specific tools. Things that I think is important that I think some of those tools at least are missing is the types of tests and validations and stuff you can run, and integrating those in with, like, say, application testing. And so I think in a lot of cases, so I talk a lot about testing of infrastructure code, and I think it's important that, like, Terraform plan is a really useful thing, an important thing to do, not testing. It's not like all, you need more than that, right? You can have the case where you run the Terraform plan, and first of all, you have to look at it and make sure you're changing anything I don't expect, and you might miss something. But also just the fact that it's going to be correct, that the Terraform apply will run and not fail, hopefully. It doesn't mean that, like, there's not some other kind of issue with a code change. And so I think what I would like to see more of in some tools is the ability to run whatever testing tool I want. So maybe I like to use the inspect tool from Chef, which is based on Ruby RSpec, and then obviously there's TerraTest. There are other kind of tools out there, and I think, like, I want to be able to run whatever of those tools I like, right? And I think supporting that, I think is important, and that's why I tend to use more of the general purpose tools, Jenkins and GitHub Actions, because I have, like, more options of what I can run. And also because then I can connect those pipelines in. I can have a pipeline job that runs in the Terraform code, and make sure that, okay, the Terraform stack, okay, and then kicks off a job that does the kind of application code, and then runs application tests to see if anything breaks there. Harder to do when you have kind of, I'd be inclined, it's like almost like a silo where there's the pipeline for infrastructure, and then there's pipelines for applications. You kind of need to have the connection between those, and maybe that's just a matter of tools are newer, and so over time they'll kind of develop more and integrate in with other pipeline tools and so on. But I guess I'm just saying that's a direction I would like to see these tools do.
Yeah, that's really currently we had, like you mentioned, Jenkins, which was before, and exponential growth of tools in all of CNCF as well as in Terraform ecosystem. And we cannot jump between like, hey, we drop previous one, but we want to use this one. It's not going to happen. When it comes to execution of Terraform tests, specifically like different inspec, or I've had lots of dreams. I mean, it's not called anyhow differently. It's just dreams that eventually a Terraform test command will work. And then, as I now run Terraform plan, Terraform apply, Terraform destroy, I will be able to also run Terraform test as just normal command. Yes, it will be integrated with my inspec controls, and everything will be possible to run. But for me, as a developer, it will be just one more command to run in my pipeline. Then I don't need to have previous generation CI tools anymore, because it will be just part of normal flow, and I can just run one more command in my pipeline when I'm about to deploy to my first environment. I want to run that my test actually do what I wanted to be doing. Dream, which unfortunately is not highly prioritized by HashiCorp apparently, because Terraform test is not working so well yet. Yes, you can run it, but it doesn't work. So that's that's unfortunate. There is a question by Dmitry. We tried to implement Monorepo with Terraform modules and Terraform stack definitions inside a Monorepo. Is it a good pattern? Kief, your turn.
Yeah, so it's an interesting one. I think Monorepo challenging, right? I haven't used it successfully. I think when we talk about what we mean by mono, there's one thing where it's like we have a single GitHub repo and all the Terraform project module inside that repo. To be properly monorepo, like to really, it's have it as a single repository. But monorepo, it means like the build. You have a single build that you run, like it's a script, and it goes and it builds all of the Terraform projects all together. And that can be quite. It's good because it's like you have all the kind of you have all the kind of versions are consistent. Like it's this version of the module. It's all like one you know uh, you know tag or commit or whatever. It's one kind of version of all the code across all the things is there. And so then when you run your commands, you kind of know. But it's hard. There's a couple of build tools for software which I haven't used of. There's Bazel and Buck, which came out of one of them came out of Facebook, and the other one came out of Google, because they both use the mono pattern. And the reason they have these special tools is because they will work out the dependent graphs and then only do builds and only run tests according to what's actually changed. Otherwise, that's a lot of stuff. And so every time you make a small change, are you going to like run test builds and applies across all of that stuff? Or do you need some kind of cleverness to do just the subset that you need and still be confident that nothing's going to break? And so it's complicated, right? And so I personally haven't that pattern. The pattern I tend to use, which has its own complications, by the way, is like, so with tools, whether you have them in a single repo or in separate repos, each mod kind of tested and delivered on its own. So you would have like a job when you change the code for one module, it's going to run tests on that, right? Maybe it puts it in a project and it has some kind of test things and so on, and then once it kind of passes the test for the module, it puts it into the repository registry or whatever for where and so now you have a new version of the module that's been tested and is used in other things. And so you do that for each module separately. And then for your stack project, your Terraform projects that use modules, you then have whenever a module changes, maybe trigger the build for that thing to like import the latest version of that changed module and run tests for the project as a whole, and to make sure did any changes in that module tests that I have for my Terraform project. And that that gives kind of flexibility, and especially where you have different people working on different things, like a team is providing some modules, another team might be making other modules, or using external modules like the one that Anton works on, and so you can have those kind of separations, but it's moving parts, right? It does add complexity to like, hey, something's gone wrong in this environment, which versions of the modules are being used. So so I think that's, and as somebody just to kind of like Dimitro there is talking about not keeping it together. I think one of the things to think about is like your actual usage patterns, right? So these modules used in multiple projects and different projects, or are they just modules that are organized for a single project? And so I think there you might think about it differently. And are the modules something we're creating and somebody else is using? And so the more kind of things where you're having different people making things for other people to use, the more you kind of need some of these to help manage, so the versioning and separate pipelines and all that help you to kind of, so that you can kind of be clear on, okay, my team made this thing, we made a change to it, does it work? Then you test, in your team, are you testing what my team made, and is okay? But then a lot of the mechanisms that we have for doing that add complexity. It's just one team working on one project. You don't necessarily need to have all of that stuff because there's a lot of moving parts to complexity. And your situation might actually be simpler than that. So something always to be careful about is we have so many tools and things to do which seem really cool, but like sometimes they're overkill.
Yeah, well, I'd like to mention that as with solid principles or Cupid principle or any other principle which we have heard or which we can go to any software developer and ask, and if they say something, please apply it to Terraform as well. What I mean is that when people say that we want to have it, let's say, next to the rest of application. We want to have our configuration or our Terraform modules next to. Think about Terraform module as a library. Would you do this with the library? Like, let's say you write in Python application or any other application. Do you really keep your libraries next to your code? Probably not. Probably you will host them somewhere outside in separate repository. You will have different CI/CD process for them. I mean, you will most likely treat them as something external. Terraform modules next to environments in the same repo or in the same like in the same project automatically means that it will be a hard time to reuse it. Like next time when somebody come and say like, hey, we want to spin up the same infrastructure which you guys have here, you will have to externalize it. You will have to put it in separate Git repository and do something about it. So always just think of Terraform modules as software libraries, which are written in just another programming language. I just wanted to mention this new project, which is by Meta, which is I remember when Git started, it was like, for me personally, it was like, oh yeah, that's something interesting. I need to learn it. And then when a few years later I discovered Mercurial, was like, oh my god. And now Meta says like, oh my god, we figure out that Git is too hard for monorepos, for like it has some weird situations with branches. It has some concept of staging, like you need to commit something, then you need to push it. And they introduced this project, which is called Sapling. I don't know how stable is it. I just want to share this information one because I find it quite interesting. Is that SCM, like source control management or source control something, or version control systems, they are not standing on the same place. So if you think that Git is all what you need and everything works, check out this project. I think you'll find it interesting as well. I have just like reading it differences, and some of these points are rather appealing to me. This is also related to Monorepo.
Yeah, I haven't seen this.
Cool. It's pretty new. It's like a few years. They were working on it behind the scenes, as far as I understand, but now they are, they just release it. If anyone has any questions, it's your pretty much last chance to ask. I mean, of course, you can always ask them later, no problem. I think we mentioned a little bit, like very, very briefly, testing of infrastructure as code. And I find that, like you mentioned, InSpec or TerraTest or some other thing, I find this a little bit lacking of time, that we are not gonna to talk about testing of Terraform and testing of like testing is essentially a required step in the process. I mean, you cannot deploy something what is not known to any environment, right? I mean, of course you can. That's what I do.
Testing and production again. Yeah.
Yeah.
I mean, it's a big topic. It's kind of getting together another time to talk about a little bit more. And it's hard with infrastructure, right? Because it's one of those things where I don't think it directly to a lot of the kind of things that you try to do with application testing. I don't think necessarily map to infrastructure testing. And so and plus the tooling is not necessarily as mature and so on. So yeah, a lot of things to talk about there.
Yeah, I think tooling in particular is one of the main challenge there. Like when I work with open source projects, I just every day I meet people who are with very different background, and I just cannot tell to all of you to learn this programming language or this tool. So it's just challenging to adopt. So we will leave it for later.
Yeah.
Okay. Right. And I want to say a couple things, or I mean, not me, but you probably want to say a couple things about your book. Or
Yeah, I
where is
mean,
this
so
link? Somewhere
infrastructure as
here.
code edition is out there, available in most of the places you can get books. It's published by O'Reilly, obviously. I think pretty relevant. It's not like code level, right? I use a lot of the examples. I use pseudocode, the concepts, because it's meant to be things that you can use and that are relevant, like pattern practices for designing good infrastructure and doing the things that we've been talking about today. A lot of that is stuff that's in the book. And it's meant to be stuff that you can do regardless of which cloud platform, even in the data center, which tool. So Terraform is my kind of tool. It's the one I use most. And so I tend to think in Terraform terms, but these steps should be usable to other tools, CDK and CloudFormation and using. And so it's at that level. I guess that's one thing to be aware of. Sometimes go looking at it and saying, "Oh, I can learn, how to write Terraform code." There's some other out there which are more specific to Terraform. But one of the advantages I found with this is I've had to do this section because there's been a move in focus from when I wrote the first edition to being less about automation of server configuration of servers and more about that kind of stack level stuff. And so that's the level that this book is at. Whereas with like the Terraform book, the O'Reilly Terraform book, up and running, which is a good one, but like he's had to kind of he keeps having to kind of refresh that. There we go. He keeps having to kind of refresh that and update it quite frequently because it is more specific and does kind of need to be updated more frequently. So I think that's an interesting dynamic. But again, like this is all the kind of stuff that we've been talking about is captured in the book and more. And I'm really interested in like people's kind of, reactions to it. And, are there things in there that are new to you or that you're not about? Maybe you have different ideas, or maybe, there's always in like, how do we make it work in practice? And so, I'm always interested in hearing from people about that kind of thing.
Yeah, and it says, I'm told to expect it out in January 2021. So it's already.
Yeah. It's a blog post, I guess, isn't it? Or is that the what you have?
No, it's book.
Okay.
Yeah.
Yeah, it's
No, but
yeah.
it's yeah. Anyway, we understand that.
2021. Yes.
Yeah. Okay. There is one more question from Dmitry Kravets. Any examples on Terraform doc usage in CI/CD? Well, one of the example we use it in all Terraform AWS modules. The purpose of this tool is to automatically parse Terraform code and provide information about inputs, outputs, resources, data sources, versions of Terraform, and so on. So this is happening on the developer machine as they commit code. So we and it just works. If you want to know more about how we use it, you can go to this project, and we use it Terraform docs, this one. So feel free to read about it, and we use it everywhere.
Yeah, it's I've kind of I haven't looked at yet actually, but if it worked that similar tools for other languages I know about use, I think it would be good to have in the pipeline, right? So to Dimitri's kind of question, it's like I think it would be have it in a pipeline stage for you doing, like say the build test and publishing say your module into the registry or whatever the kind of appropriate thing is to have a stage in the pipe automatically make sure it generates that and publishes it to the place. Some organizations, so at ThoughtWorks where I work, we're doing work with clients, larger clients on developer portals. We work with like the Spotify Backstage portal product a lot, right? And the idea there is that like developers can go find these kind of resources, right? So that's a good kind of thing to hook it into to say that like somebody portal, a developer portal, and see, okay, what does this module provide? What do I need to kind of, what's an outputs and so yeah, I think using the automation is really helpful to make sure that is kept up to date, right?
Yeah, so what we also do with this one is that we have this pre-commit config, which we execute on developer's machine. But if developer want to skip it for some reason, then it will not be executed. So then we execute it as part of our GitHub action workflow, where we still execute the same pre-commit hooks, just to double check that developer actually, where was it? Terraform docs. So this action will be executed, and we will just make sure that documentation is up to date. So we execute it every time on pull requests to make sure that things are always correct. So here, actually, if you are interested about what we do with Terraform modules, check out Terraform AWS modules, same things. And pre-commit workflow does everything, like validation with different versions of Terraform in different ranges, because sometimes you want to you don't know that this feature is so new, and you think that version constraint is valid. So this is really important that we do this for different versions, for minimum and for maximum. So that's it. We also update other checks. So yeah, that's pretty much it. Okay, I think we have one more.
I think that was just a comment.
Dmitro, oh my God, there are so many Dmitry and Dmitro today. Yeah, guys. It's a real nightmare when developer or your teammates are not using pre-commit hooks. Yeah, so that's why we need to enforce this action so that people are not able to skip it.
Yeah. Or if they skip it, then you stop and it catches it.
Yeah, then machine will tell them that, haha, you skipped it. Not me, but machine. That's good.
Yeah.
I like it. Yeah. Okay, great. I think that's it for today. Thanks everyone who attended. Big thanks, Kief, bringing your experience and your knowledge. Share it with the community. I highly appreciate it. And I will update links everywhere. Yeah, in README.
Yep. Thanks for having me on, and thanks for everyone for joining in. It's fun.
Thanks. Bye.
Cheers.